Hello everyone, my name is Rajesh Kumar and I'm your Devops SRE DevSecOps coach. Okay, so today we are going to learn about Docker. So the first question which you may ask and that is, what is Docker? That is a very first question you may have in your mind. So now guys, when I look at the Docker, I see this tool is basically doing nothing but container management tool or platform, whatever you now call it. So now next thing which you want to understand, okay, what is a tool? So tool typically we use a lot of tools you use every day, right? And as you grow in the industry in SR in DevOps, you'll have a lot of tools actually. So you will use so many tools, and why we use so many tools? Because it will save cost. It will help you to, save time, and this will help you to also improve the quality, right? Quality is important, right? So now the question you should ask, okay, how the containers will help you to save the cost, how the containers will help you to save the time, how the containers will help you to in terms of improving a quality. So let me put it up in this way. Let's say if you're running one physical server and probably it's taking one 2 GB, let's say example 3 GB. Now, if you have, I'll put it in this way. Let's say you have a 3 GB hardware, okay, of memory and one CPU, two CPU, whatever it is. And if you're using physical server, probably you can create one physical server. Let's say probably you're using virtual server, and probably you can run two virtual server in the 3 GB. And if you are running containers, probably you can do 10 containers, and that is the reason we can save lots of cost. That means here you are running one application consuming 3 GB, here you are running two applications and consuming 3 GB, here you are running 10 application, so consuming 3 GB. So now the question is, you must be having like how it is saving the container, is saving the uh, sorry, so container is saving the, all the resources like memory, CPU, disk and all. So that has been designed in a way, it has no container, has no operating system, okay. And so that memory, CPU and storage and licensing cost get saved, whereas in virtual server and physical server you have a operating system. So that's a technology we are trying to learn. So here this will save cost. So now you understood that, okay, if you run the container, definitely it will save cost in terms of resources. Now how it will save the time? So let's say if you want to run application in physical server and if you want to set it up, probably it will take one day. I'm just giving you, let's say if you have a virtual server, probably it will take 5 minutes. Virtual servers like cloud and all. And let's say if you're running in a container, then it will take 1 second. See, so you are running the application using container, so you are saving a time also, correct now? And the same time, it will also improve the qualities as well. Why? See, when we save your time and cost, let's say you want to set up a dev environment, okay, you want to set up a dev environment. Earlier when we were having virtual servers, probably used to take, let's say, 4 hours. Now you know what, with the containers, now with the containers, you will spend only 1 second, right? Because the whole environments you can create using containers and 1 second. So this way, you saved lots of time for setting up the infrastructure or whatever it is, running the application or whatever it is. So you save time where you will spend. So whatever the time you saved, you will spend with the code quality and test quality. And if you focus on the code quality and test quality, then ultimately you will improve the quality of the software. Make sense, right? So this is the benefit. If someone will ask you, hey, what benefits you get from the container, you say, in a containers we can you run application with the little resources. Resources means CPU, RAM, storage, no licensing cost. Same time, using containers, we can create a applications. We can run application in within a second, and it will help to save lots of time and lots of effort, lots of complexity, and many other benefits. So now the question is, okay, tools, you understood that, but what is the meaning of management? Okay, so before understanding the management, see, I think most of you have worked with the vSphere, VMware, VirtualBox, AWS, something like that, right? Many hypervisor tools. So what, let's say what VMware is doing. So VMware is doing nothing but managing the VM, correct? No, managing the VM. So here, if we say in terms of VM world, okay, in terms of VM world, let's say VMware, it create a VM, right? Then you can start the VM. You can also stop the VM also. You can again restart the VM, start the VM, and then restart the VM, right? You can pause the VM. You can unpause the VM. Okay, unpause the VM. You can kill the VM, and then you can remove the VM. So these are the things you've been doing from last 20 years plus in VM, right? Right. So now the question was, what is a container? What is so container is, I mean, what is Docker? So Docker is a managing container. So when I say management, that means what? So here management means basically Docker can create container, Docker can start container, Docker can stop container, and Docker can restart container, pause, unpause, kill, and remove. So all these things can be done by Docker. Okay. So now the main question what you should be having is, okay, I understood Docker can create, start, stop, restart, pause, unpause, kill, and remove. So what is a container then? This is a very important question you need to understand. So far so good. Any questions, any doubts?
Yeah, hi Rajesh. Am I audible?
Yes, yes.
Yeah. So I have a question regarding the time saving. The comparison which you have done 1 day, 5 minutes, and 1 second. So this comparison regarding the development of the application or deployment of the application, I believe deployment is it?
Running applications. So for running
Running
applications,
application. Okay.
you
So
need to install something, right? If you want to run one application, you need to install something.
so
Uh,
okay, that is not running. That is installation and configuration of the application.
but when I say the context, we should take it in this way. In order to run application, what resources are required? And that resources, either physical server you have, virtual server we have, and containers we have. What I'm saying, same resources, you can run more container, more applications. That is what I'm trying to say.
Okay, because in my what I have seen so far, I never seen this 1 day, 5 day, and 1 second comparison. 1 second is I think there is something.
Okay,
Uh,
I'll put the context. Let's say
mhm.
I'll give you a simple question. Let's say you are using AWS or VMware. And if I ask you, hey, go and run some application, let's say Apache, and I'll ask you how much time you will take.
Okay, running a application will take for all most of the platforms a similar time when we say the starting the running the application. But when we say installation and configuration, it takes a lot of time because for
Yeah.
that you need to install certain modules, you need to install certain libraries and dependencies. In
Right.
container, everything is in pack or you say zip format. You're just extracting it and deploying it. But
Aha,
still, one
aha.
second, it will take more than 1 second. That's what I'm trying to say.
Okay. So let's put it in this way. Let's say you don't have to install. You have a fully sufficient AMIs ready. Okay, everything is there in the AMIs, machine image, and you just go and create a VMs. Probably if you create a VMs, at least 2 to 3 minutes, it will take an up it, in the virtual machines. Correct, right? I'm talking about that way. Now, same way you only said in Docker, we have an image, everything you have it. In VM also we have everything, but in containers also you have everything, but it runs faster. Like the moment you run the command docker run xyz, I'll show you the demo, you run it. But something which you do with the in the VM, it will take few minutes, right? Based on that what applications you have. So in that context, what I'm trying to say, yes, if you want to set up or run applications, then compared to physical servers, virtual server, container is consuming less time. Let's say you want Apache. Simply you go Docker run Apache. You don't do create a VM, do this, that, and a hell lot of things, right? Something like that I'm saying, putting in a context.
Okay.
Yeah. Okay. So now next question is, what is container? So now guys, this is a very important question, and this is also very difficult topic, and which required lots of time to explain it in a better way. But I'll try in next 10 to 15 minutes. I'll try to explain it to you, though not getting into the deep dive because adults will lose the time for it. So now the question is, what is container? So guys, understand that it's all about you want to run applications. Okay, so container, there is one functional definition which we have, and most of the people, if you ask a container what is container, they'll say it is a lightweight, okay, application runtime environment. That's all. It's a lightweight application runtime environment, and this keywords has lots of meaning. When I say lightweight, that means you should compare this one. So that means lightweight means this container consume lesser CPU, RAM, and storage compared to the virtual server. That's why we call it lightweight. Now, application runtime environment means, let's say you want to run some Java-based application. So what is required? You required OS plus Java at least, right? So that's the environment. So in a container, you have every, someone was saying, in an image you have everything in a container. So that is what I said. It's lightweight app runtime environment. This is a functional definition, but there is a technical definitions also, and we need to focus on the technical definitions. So now, though I have a limited time, okay, I will shorten this discussion in terms of defining the technical definition. So now, guys, a very simple question. Forget about the Docker, forget about the container. Focus on what is required to run one applications. That's all. Simple question. You focus on it. Okay? What is required to run one applications? You can also say what are the resources. I'm redefining the question. What are the resources required to run one app? Now, when I say one app, let me give you example so you'll fill a context actually. So this is my machine, and I've not restarted from last couple of days. And if you see that so many applications I'm running. My God, see here, look at this. So many applications, so many Chrome, so many Firefox, so many utilities running my machines. More than, I think, 200 if I'm not wrong, right? So one application I'm talking about, not everything. Let's say one GoToMeeting or one Chrome or one a Skype, because I am running 200 application in my machine. But here I'm asking you to focus only on one application. What are the resources required to what are the resources required to run one applications? So let's start with. So guys, we know that nothing great. Everything first we need a hardware. Now I'm not going to define the hardware because you know that. But based on that, you need an operating system. Okay, this is something which you need to discuss. Operating system. Now, when I say operating system, it has a many things actually. What is has? So let me define the operating system. So the first thing which we have is kernel. Okay. Okay. And then on top of kernel, then you have a root file system. Okay. Root file system. Now, this when I say kernel, it is a boot file system. Kernel is also code, right? So you have a boot file system, which is a kernel, then a root file system. Now you may be having question, what is a root file system? Boot file system, I told to you, kernel. Kernel is a code which runs uh, between the hardware and software, right? So human. So what is a root file system? So let me ask Google, probably we'll get a faster answer. So I put it in the Google and now I got this one. Now my questions to all of you, do you know this? What is this?
Oh, this is the layout of the file systems of an operating system.
Yeah. So actually we call it a root file system. You see, starting with root, whatever you see, it's in root. We call it a root file system. So it's a part of operating system, so that we know that. In Windows also, if you go C drive, program files, window users, this directory, that directory. So this is called root file system there also. In Windows also, Linux also. Okay. So this is the something kernel you have, and then root file system you have. Now what you need? What you need? Kernel you got it. Rule file system you got it. What else you required? I don't know. Let's understand from this one. Okay. So let's try to focus, because though you can understand the architecture of Linux, but I'm using Windows for the discussion because that way it will be easy to understand. So guys, let's understand that this is one application, which is Skype, one application. Now the question is, what else required? So Skype will be copied under the C program files, right? So this is coming under the root file system, root file system. Okay, that is a root file system. Sometime also we call it MNT in container. I mean container world. If you read the official documentation, they'll call it MNT, means mount. Okay? So this is the file system. But the question is, in order to run, see this is running, right? For running, what you need? So in order to run, you need one PID number. You see that PID number? You see that any process, you look at this here, any process, do you see that without a PID number? No. You see everywhere PID number. That means any applications you run, you need a PID number. Now the question is, how do we get a PID number? That is a question, right? So we get all this PID dynamically allocated from the kernel. So PID, we needed one PID. Now the question is, what else we needed? So now guys, we need a CPU and RAM. Here you see CPU and RAM. Without that, you cannot run applications. As long as the application is in running state, you require certain CPU and RAM. Maybe if you're not using if you're not using application, the CPU will be 0, but the RAM will be used. But the moment you are using the application, CPU will be used. If you know the kernel, that's a behavior of it. Okay, so the question is, you need a CPU and RAM, right? Now the question is like, who's allocating this CPU and RAM? So there is one utility which is in kernel, which is called C groups. Okay, in kernel. Okay, I'll show you that little bit later. Let's understand that. Okay, so now what? See here, Skype, PID you got it, CPU and RAM also you got it, and one more thing you needed. Any idea what else is required to run any application? You have an answer in front of you. Can you please help me out?
User, user which
Yeah.
runs that application.
Yes. So for every application, look at this here. You won't find any application which is running without user. Sometime local, sometime Rajesh. I made a mistake. H, I forgot that while configuring this server, this laptop, and local server user or whatever it is. So you need the user. So now you need a one user also. Okay. Now guys, I must also add one more thing which is required, and here though in this scenario is not there. Let's say you are running HTTP, application is HTTP. So this application, how can you access? You can access through the browser. correct now? And this browser, in order to access the browser, it's required network, right? Correct now? IP address and all. Agree with me, right? If it is a web-based application, right now I'm not running any of these web-based, but let's say Apache, Tomcat, or certain web-based application, you need a network, right? So yes, you need a network also. So now if someone will ask you basic question, hey, I want to run applications in, I want to run applications. So tell me the fundamental, what resources are required. So you say, okay, it's a hardware needed. That means laptop or physical server. And then on top of that, we install the kernel, which is typically a part of operating system. Then on top of that, we have root file system that is also part of operating system. Then each application is required one PID, which is allocated by kernel. Then CPU and RAM, which is also allocated by kernel, part of C groups. Also, one user is created to run that application, that is also taken care by kernel. And then one network is created, and that is also taken care by kernel. So now if that is the question is, what are the resources required to run one app? Are you comfortable? Hello? Hello? Audible?
Sorry, can you repeat the question, please?
The question was, what are the resources required to run one app? Are we clear on this?
I suppose so.
Okay. So now, guys, we need to understand a little bit kernel in detail. So kernel is nothing but a programs, software programs, and it has a, it's, I'm not teaching you kernel right now at a high level. So kernel has a, some of the concept called namespace. Okay. And then C groups. You need to know these components if you really want to understand the container. And then we have a one more capability. Okay, there are few more, but not complicating it. Again, in namespace, there are four different kind of libraries we have. There's one library which is called MNT. There's one library which is called net library, net namespace we call it. There's one library which call it a PID namespace, and there's one more library which we have MNT namespace. MNT no, user namespace. So what is exactly is doing this MNT namespace creating? Remember that this MNT namespace can, let me put it up this way, can allowed. Understand this. So can create what? Can create multiple root file system. Yes, I repeat, multiple root file system, the one which I showed you here. Multiple, it can be created by this MNT namespace. But how do, I'll put it in a more simpler way. Multiple C drive, it can be configured using MNT namespace. But the question is, how many C drives you see in real? Only one. So that means operating system allow only one mount, one root file system. Here, how many network you can create? Multiple, where allowed is by operating system by default one. How many PID you can create? Multiple, but, and okay, so here when I say PID, that means here I'm saying PID tree. Okay, don't get confused. PID versus PID tree. Now you will ask Rajesh, what is difference between PID and PID tree? So guys, understand that this is the PID number, you know, but there is a tree. Always there is a tree. Let me draw pictures. You'll okay, here only I can draw. So here every PID tree start with 0. Okay, then after that 1. Now one typically, you know, it is a part, it is a Linux which is running, kernel, kernel is running. Then you logged in, you become a 2. You logged in and then you run Apache, you become 3. Then Apache calls something else, 4. Someone else logged in, 5, 6. So this whole structure is called one tree. Okay, so now here uh, in the virtual server or laptop, one is allowed, but actually multiple you can create it. Let me show you rather than talking. See here, this is a pit tree, right? See, starting with 0. See here. And then first process is this one. This is running kernel, NT kernel and system, right? First process after 0. So 1 and 2 and 3, it was a temporary process has gone actually. Okay. So everything start from the 0. You see that? Everything start from nothing, not a thing. Okay. So here, now the question is how many users you are allowed to create in the operating system? Multiple. And how many is allowed? Multiple. Here you can create a multiple user, mind it. So when understand that what I'm trying to say, when you have a kernel, then actually you get only one MNT, means one C drive, one network, one PID tree, and multiple users you can have it. Whereas capabilities is it can create a multiple MNT, means kernel can create multiple MNTs, multiple network, multiple PID tree, multiple users also. Kernel has that capability. But that Microsoft and Linux do not allow. Why? The concept is PC concept. Remember that. What you will do with a multiple C drive, what you will do with a multiple network, what you will do with a multiple pit tree and multiple user. A multiple user you and your friend can work or your family can work, right? Because we design this architecture for PC. PC means personal computing for human being. We did not design this architecture for running a data center. Though, because of the growth which we have with the internet, we started using the same architecture for the data center. And that is where that we have a problem in terms of cost, I mean resource wastage. Now the coming back to the question, what is C groups? So C groups is managing CPU and RAM and allocating to the PID. Capabilities defining user access, like root access or non-root access. So guys, this is something which you have in kernel, and this because of this, without you knowing, these processes works actually. Let me show you one image. Probably you'll have a little bit conceptual knowledge as well. So Docker namespace and image, and this is one of the best image. I think you should check this out. See that. Look at this. Focus on the kernel part. Linux kernel, C groups, namespaces, capability, few more, and this is the Docker. Okay. So now you are trying to understand the architecture, but then you'll say, Rajesh, you are not answering my question. What is container? So let me put it now. What is container? So that can be done through image. Okay. So now guys, you understand the basics. Okay. So let me tell you, when you want to run any application, let's say I'm talking about the VMs world. Okay. So what happens? You have a hardware layer, and then on top of that, what you do, you install operating system. Okay. And I must remind you, this operating system, you have all this thing, right? All this thing. Okay. So now what these things will create? So this thing will create your one network default, one PID tree, one mount, and multiple user. Multiple user 1, user 2, user 3. So this is the mount, this is the network, and this is a PID tree. Okay, so now this user who has logged into your machine, he is having the same C drive, same C drive, same C drive. This user has all the same network, same network, same network. This user also using same PID tree, same PID tree, same PID tree. Are you comfortable with this image so far? Hello?
Yes.
So now guys, each of these user can run different applications, right? You see that here live only. So many applications running by multiple user. You see system user, Rajesh user, local user. So here there is one application has run, there is one application has run, there is one application has run. Now try to understand the disadvantage of this model. Okay, So the problem what we have in the data center, we cannot run multiple three Apache. Apache 1, Apache 2, Apache 3, or MySQL 1, MySQL 2, MySQL 3, or Tomcat 1, Tomcat 2, Tomcat 3. We can run only one in one machine. Why? You tell me. Why do we run in a data center one machine, one applications? Why do we do that? Why do we do that? Anyone?
Because of the resource requirement.
Uh, One simple reason is we all are running one application, one machine. The reason is load balancers. Without that, nothing will works in the whole world, right? We have a 5,000 applications of Apache. You need a load balancer. You cannot run every. See, we don't run huge resources one machine. We run small resources 10 machine. Why? Because one machine is down, second machine will be up, third machine will be up. So there are some fundamental reason availability to make it application available 24 by 7 without a single second of downtime. You do not run everything in one machine. You run in a multiple machine, and then you load balance through the load balancer. That is what we do. So that is a fundamental reason. So guys, this model, the one which I'm discussing right now, this is good for PC, human, not for data center. In data center, we run one application, one machine. That is a problem. Now the question is, what do we do in this case? So there is one guy, okay, his name is, I forgot his name just now. Uh, Let me find out. I forgot just now. Solomon Hikes. Okay, this is the guy. Okay, here. Okay, so this is the guy. He said, let's do one thing. Let's do one thing. Let's do one thing. Let's say, I would like to tell you one more thing. Let's say you are running three application in data center. Okay, so what will happen? The drawbacks. Let's try to understand this. One and one, and let's remove this two applications. This is the data center scenario I'm creating. Okay. Okay. What is the problem in this architecture? What is the problem? Tell me. In this architecture, what is the problem?
Not actually a problem, but might not be the best solution, right?
Okay, so the problem in this architecture is a general the general use cases what we have. Three application, three VM we run it, no problem. And each VM we have a kernel, right? Linux kernel or Windows kernel. But the problem is, understand this guys. Problem is you want to run three applications, and in order to run three applications, you are running three kernel. That is a problem. Because for running a kernel also you need a CPU, RAM, storage, license card. CPU, RAM, storage, license cost, and that is a problem. I wanted to run three application. For that I need to run three VM, three operating system, and then that is a problem. What do we do in this case? So what Solomon Hikes did, what Solomon Hikes said, let me show you, let me tell you what Solomon Hikes said. This is the architecture I'll improve. See here, can. Remember that. MNT, net, PID, user, can, right? So now what Solomon Hacks did, I will write one utility. Okay. I will write one utility. Some or top of this, I will run somewhere here with certain user. Okay. Maybe, sorry, maybe here with certain user, root user. Let me change the color. This is the one. And this utility, you know what? This utility will talk to kernel. Kernel. This utility, I will write it. Solomon Hayek said, I will and talk to kernel. Then you know what? They lots of fight started happening. Why the fight started happening? Because see this image. Now the Linus Torvald, who's the father of Linux, they said like you can't access the kernel by utility. See, your tool which you are trying to develop is against the fundamental of computing. You are running certain applications as a user, and if this user can access the kernel, it can destabilize the operating system. You cannot do that. So it was rejected. That Linus Torvald rejected that plan. Linus Torvald said, instead of you are accessing the kernel, let's do one thing. We have some utility like a systemd spawn, lxcs, libvirt, libcontainer, and containerd. Now containerd, these are the utilities there which has allowed to access the kernel. So what you can do, you can write your code which will support this one. So now if you look at the architecture, this is the historical reference. Okay, it started with systemd, now it's containerd, libcontainer. This image is also outdated a little bit. Okay, so now what has happened? Now Docker is able, I mean, this application is able to talk to the kernel using some of the extra libraries which is allowed by kernel. And now this extra library is the one which is running and asking, hey kernel, can you create, understand that very simple way. I'm saying can you create one pid tree, one network, one mnt? And kernel says yes, I can create. Hey, again he asked one more time. Again he asked one more time his resources. So now kernel, because it was already there, this feature was already there from last 20-30 years. So kernel did this. So that, so now next time what this utility said, hey kernel, can you do one thing? Can you create one more user and this user attached to these resources? Can you create one more user and these users attached to these resources? Can you create one more user and this user attached to these resources? Can you do that? And kernel did that. And now this user using this app, running one application, one application, one application. I must remind you, this application is using this C drive, this IP address, and this bit tree, this MNT, this bit tree, this network. So this user is running one application in isolated way and has their own IP address, own root file system, own network, own bit tree, everything isolated, independent. Are you understanding, all of you?
Yes. Yes.
Yes, yes.
So now the question is what we call this guy? Because we can't call it a normal user. This guy is a special user, right? What we call it? And any guesses what we call it? Container. This we call it a container 1, container 2, container 3, and container. You see that there's no operating system because all these containers are using the same host operating system. So now coming back to the question, now you want to run 3 container. Do you need a 3 operating system? No, only 1 operating system. And in that old case, you remember 3 machines, 3 VM, 3 application, 3 VM. So now here you can save a cost, and that is what I was trying to tell you through my notepad. Saving cost, where is that? Somewhere here. That means you can save a cost, and this was done because of the re-architecturing the whole compute environment. So now the question is, what we call this one? What we call it, this utility which is in yellow? This is called Docker. So Docker talk to kernel with the help of certain libraries and create all these resources. Basically all these resources which is, we call it a container managed by kernel, but it is based on the request from Docker. So now the question is, what is container? So guys, container is a collections of 1, network, one MNT, one user, and one what do you say, PID tree. PID tree. Yeah, that's all. Now this is something which you understood. So now are you clear what is a container? All of you? All of you?
Yes, for me, explain.
Okay, cool. So guys, let me conclude that. So now, again, one more thing. I think you need to know the advanced Linux kernel also in order to understand this. I have some recordings videos I'll share with you. I have a few more channels where I keep the recordings and all. So I'll share with you. So if you are interested to know little bit of kernel and all, then you should get into that. Though now this is done. So now the question is, what is a Docker? Docker is a container management tool. Why do we need it? You have a region. What exactly Docker is doing? You have a region. What is how it works? Containers. You know the region. So guys, this tool is written Docker written in Go actually. So that means Go is a platform independent. So Docker is supporting Linux only, but 2019 onwards they started Windows also. So they have a multiple release. Okay, they have a community release. They have an enterprise release as well, and so on. By the way, now current format, this is free and open source actually. Okay, so this is your Docker. Now next question, how Docker works. Docker works. So I think more or less now you understand the architecture. So let me tell you. First of all, you are the person. You will send a request to Docker client. Docker client using API send the request to Docker D. Docker D means Docker server. Docker D will send this instruction to container D, which is a utility which is being used by kernel, and container D will talk to kernel, and then he will get resources, one network, one PID, each container by the way, okay, each container, one PID and one what is it, MNT, and one user. This is equal to one container. So this all these thing but done by kernel but requested by you. Out of which this this two part, we call it Docker server, Docker client and Docker. Just avoid the spelling mistake. Many I'm doing. So this is the Docker server. So now we need to install Docker server. Okay. And then you will get a client and then Docker server container D. And then what we will do? We will do this one. That's all. Nothing great. It's very easy. Doing the things is easy. Understanding it required certain efforts. Make sense, guys, all of you?
Yes.
Yes,
So
yes.
the question is, can this be implemented in personal computing? Is it existing? Anybody?
Yeah.
Any?
If yes, if you have a 2019 plus, it can be done. But if you do not have a 2019 plus, then you can install the Linux VM in your in your Windows, and then you can start working on it.
You also have Docker Desktop to run on Windows.
So Docker Desktop, what exactly internally is doing? Docker
It's
Desktop
similarly
internally,
creating a small VM to run Docker, basically.
correct, 100. You are right. Same thing I was about to tell you.
Will these Dockers have persistent state or temporary state?
See, the answer is both yes or no, but the question is we have to put in a context. Because if I say there are many ways to make it the container persistent, but by default, let's say if you do not opt for those options, then it will become a inferal actually.
Okay, can I
run the same application in the same container multiple times? Can I stop, start, do all that?
No, those concept is little change here with the container. So I'll show you the some demo today, but again we'll have to explore in order to become expert in that. Okay, so guys, next question is, you want to learn Docker, what to do? So I call it Docker components. That means if you learn these components, you will learn the Docker. So first thing, components, right? Spelling mistake again. Components. Okay, so these are the four components you need to know if you want to learn Docker. What is that? The first thing is you install Docker. So you will have to do that. So the moment you install Docker, you get Docker client and Docker D. Second thing, you go and download Docker image. Now the question is, what is a Docker image? Guys, it's a very simple concept. When you create a VM, then you have a VM image, correct? We call it a machine image also. So same way, when you create a container, you have a Docker image. This is important. And Docker image we need to understand. Now then you will say, Rajesh, what is the difference between VM image and Docker image? So let me tell you, guys, any image you see, they have a boot file system. If you remember, here I discussed a little bit of it somewhere here, you see. So any image you have a boot file system, and then you have a root file system. Then on top of that, you have a some user file system. User file system means desktop, and then application file system is equal to your image. Example, boot file system is your kernel. Root file system, let's say Ubuntu. Yeah, Ubuntu is a root file system. RHEL is a root file system. CentOS is a root file system. Kernel is a Linux. Okay, so understand that. So whenever you call it, you call it Ubuntu. Actually, it's not operating system. It is just a root file system. What they do, Ubuntu community, what they do, they copy the Linux kernel, put their own utility on top of it. This is called root file system, and then release it into the market. And then user, let's say root and applications, let's say ls or maybe notepad or whatever it is. I'm just putting in a simple way so you understand. So now the question is, what VM image contains? So VM image contains everything. Then you will ask, what Docker image contain? Guys, Docker image contains only from the root file system. That's all. Yeah, plus user file system plus application. That means here when you say I want to run Ubuntu container, that means you have only root file system. But when you say no, I want to run, let's say Tomcat, so in that case you have a root plus Java plus Tomcat, and then some user also. User, are you understanding what I'm trying to say?
Yes, yes.
Okay, so guys, this is the Docker image. Simple way I'll put it up. If you want to create a container, you need a Docker image. Then you will ask, Rajesh, from where we get the Docker image? So guys, there is a Docker Hub registry. By the way, there are so many registry in the whole world, but right now Docker Hub registry is the one which is for learner purpose. Here, I'll take you to there. You see here, and this is the one. And you know what? Here you can find lakhs of images. Yes, lakhs of images. Whatever images you can imagine, whatever application you can imagine, you will find the image here. Can you upload your own image? Yes, you can do that. You can sign up just like a GitHub. Docker Hub is like a GitHub. You can upload it. And these are the images you see, and lakhs of images are there actually. Some of the images, like say today I'll try Apache, right? So where is Apache? I can't find quickly, you have to search. So here Apache, enter. See, this is HTTP Apache. This is official image I'll use today for this session. This is the image. Apache community has published this image, official image. How many times downloaded? 1 billion times has been downloaded. Are you understanding, all of you?
Yes, yes.
Yes.
Yeah. So this is something which you need to do. So Docker Hub, you will download the image. No, first install the Docker. I'll teach you. Then download the image from where? Hub. And then finally run the image and you get one container. Simple. Using Docker, that's all. So these are the 4 steps in order to learn the Docker. Run the image. How to run that image, I'll teach you. Don't worry about that. So as many times you run the images, you'll get a more containers. Something like I'll show you the demo, then it'll make sense. Okay, so now demo time. But before that, before the demo time, let's have one break. Okay, so grab your tea, coffee, restaurant, and personal calls, and let's connect to the same meeting in the next 20 minutes. What I will do, I will close the meeting, but immediately start the meeting also. So that way, those who wants to join that again, in order to avoid the time confusion, you can be in the meeting actually. Okay.
Sure, sure. Thank you.
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.